Hello, my dear friends. Hope you all are fine and safe in your home. Today we will discuss chapter light. It plays a vital role in 10th class syllabus. We will discuss this chapter little bit elementary portion from the chapter. Uh, we will cover in this video topics like what is light, how it produces, some historical background, how actually light discover, whose contributions are there, some well-known theories like electromagnetic theory, quantum theory of light, corpuscular theory given by Newton. What do you mean by electromagnetic spectrum? What is mean by dual nature of light? Why light so dual nature? So all these things we will discuss. First is what is light? Simply, dear cadets, it's a radiation. Type is electromagnetic. Now let's split this big term electromagnetic. It's summation of electric B denoted by capital E and magnetic that is denoted generally by B. According to many scientists, if electric field and magnetic field simultaneously present, then they can produce radiation. And if the radiation have wavelength between 400 to 800 nanometer, then only that particular type of radiation will be considered as light. Clear? So electromagnetic radiation does not means light always. Light is a small part from this. Nanometer, you may know it, small unit of length. 1 nanometer means 10 to the power minus 9 meter. Clear? Okay, let's proceed. Optics. It's maybe a new term for you, but it's nothing but light. Study of light means optics. Dear cadets, once upon a time, optics or light was restricted in the observations, visions, all these things. Clear? But slowly, many optical instruments like mirror, lens, laser, telescope, microscope, slowly those discovered, and with the whole help of those instruments, lot many new property theory of light came to know. There are a lot many scientists who contribute in this process of discovery. We can take few well known name who are related with the study of optics like Socrates, Aristotle, Plato, Maxwell, Huygens, Young, Einstein. Today in this video we will learn something about Maxwell, Huygens. Clear? Okay. Let's move. Four basic theory are there given by Huygens, Newton, Maxwell and Planck. We will try to cover those four theory little bit. For better understanding, our base should be neat and clean. Okay? Wave theory is given by the young scientist Huygens. Lot many European scientists support this wave theory. According to Huygens, light propagate in terms of wave, and he mentioned shape of the wave will be sphere type. One part from this wave, he give the name wave front. Clear? According to Huygens, each particles situated on this wave front. Clear? I can just draw lot many particle on each of the wave front. According to Huygens, each of the particle is secondary source. Clear? So this type of theory is given by Huygens. No. Next theory came from Isaac Newton from his famous experiment, prism experiment. According to Newton, just light is the shower of particles like from machine guns lot many bullets are coming. Similarly, Newton believed from the source lot many light particles are coming. He also believed size of this particle is different and they contribute different colors of light. Clear? This is known as corpuscular or particle theory of light. Another theory given by Maxwell, electromagnetic, means electric and magnetic. These two fields produce light. He think that suppose at y-axis electric field is there and along z-axis magnetic field is there. So according to Maxwell, light will propagate towards axis x. For better understanding, we can take the next help of next picture also. Suppose this represent our B magnetic field and that represent electric field. So light will be towards x-axis. So this type of theory is given. Later we will learn in details. This picture may help you the understanding of electric magnetic field and how they produce the light. Fourth theory came from scientist Planck. He introduced the concept of quantum theory. According to Planck, a light is not a continuous event. Clear? According to Planck, light can be splitted into many parts. Suppose let us consider incoming and reflected ray. According to Planck, this ray can be split into so many small parts. So here I have taken 4 parts. For example, each of the part have some particular energy. According to Planck, this energy expression is h nu. Here h is called Planck constants having value 6.626 into 10 to the power minus 34 joule second, and nu is the frequency of the radiation. Whatever radiation we are discussing, that frequency is nu. So according to Planck, the energy of the light is solely determined by the frequency of the incident radiation. No doubt it's a historical discovery. We can solve some numerical problem based on this formula. It's very easy, hardly 2 or 3 lines. Let's solve. In first question, light frequency is given 5 into 10 to the power 14 Hertz. So let's calculate energy. E equals h nu. We know h equals 6.626 into 10 to the power minus 34 joule second. Nu equals 5 into 10 to the power 14 Hertz. Hertz means 1 by second. So we will put that value 1 by second. Now this second will cut. Now we will do the calculation and the value will be like this. Clear? Okay, answer is joule. Unit will be joule. Okay, easy. Chalo, let's move to the second question. Radiation is given with wavelength 3.3 micrometer. Good. Let's solve it. Now, expression for energy is E equals h nu. In class 9, we have learned in sound chapter, nu frequency can also be written as c by lambda, velocity of light by wavelength. In higher class, the proof will be there. Now we will prove the value. Okay, c is 3 into 10 to the power 8 meter per second, and lambda will be given as 3.3 micrometer. What is this mu? Micro means 10 to the power minus 6. So we have to put that value and simply we'll do the calculation and it will come like this. 6 into 10 to the power minus 20 joule. Easy. Okay, so try to understand. If you have doubt, please drop your question. This is electromagnetic spectrum. We have learned about electromagnetic radiation. That means a radiation, a wave that produce because of E electric field and B magnetic field. Now so many waves are there, not only light wave, so many other waves are there. We can plot them. Let's start with gamma ray. Gamma ray wavelength end at 0.01 nanometer. Clear? After this X-ray, its wavelength is up to 10 nanometer. Next, ultraviolet. After ultraviolet, our visible lights start with violet, about wavelength 400 nanometer, and ending with light red, about wavelength 800 nanometer, and at the middle yellow, about wavelength 600 nanometer. So ending with light red. So after red, what will be? Infrared, correct? After infrared, microwave and radio wave. You can observe slowly wavelength is increasing. That means frequency decreasing, so energy also decreasing. So gamma ray have maximum energy. Next, dual nature of light. Sometime question came from this topic, so you should have a clear and neat idea. We discussed that light is wave given by according to Huygens. Light is wave, correct? Okay. So from this wave theory, you can explain reflection, refraction, superposition, polarization. Clear? Most of the topic will come to you in class 12. And these two topics now we will discuss in 10th class. Photoelectric effect again will come in 12. But dear cadets, to understand photoelectric effect, we have to assume that light is nothing but particles. It means light is wave and also particle. That means light have two nature, wave nature, particle nature. Dual means two. That's why we tell it dual theory of light. Next question is how light produce. Dear cadets, you may have a wrong notion that light produced by tube light or bulb or torch, that's all. No. How light produce. You may see light is coming from torchlight, tubes or bulb. But that is not the answer how light produce. For understand how light generate, we have to move or go up to the atomic level. Let us consider an atom having an electron in cell 2. So now I am thinking in third cell no electron is there. Clear? So only one electron present in cell number 2. Under this situation, let's give a radiation from a torch. When this electron present in cell 2 just face the radiation and absorb, its energy will be more, so it will jump into the next higher energy cell. But after some time the electron will think, oh, this is not my own home, so it will jump and come back to the own state. So the extra energy it will radiate, that is a electromagnetic radiation. A radiation will be there. If that radiation have wavelength between 400 to 800 nanometer, it will be light. Otherwise, any other electromagnetic radiation it will be. So this is the actual answer how light produce. Clear? I think you understood. For better understanding, here I have add a moving picture where you can see radiation is coming, electron got and come to third cell, again release and light produce. Properties of light, it's easy. You please note down this. Okay, our next slide is light travel much faster than sound. Yes, really, the velocity of light is tremendous. It's about 3 into 10 to the power 8 meter per second, means about 3 lakhs kilometer per second, while sound velocity is 342 only. Also, the sound velocity can vary based on the atmospheric pressure, temperature, moisture, all this thing. Light velocity is so high it can travel our Earth 7.5 times per second. So it's really large. Sometime one question came to our brain: can anything can move with velocity of light or more than this? No. Let's try to understand it. Clear? Let us consider a human being having mass m and length is L. Clear? Now he is moving with some velocity v. Slowly he is increasing his velocity. Then what happen? Mass will increase and length will decrease. According to the Einstein's general theory of relativity. In higher class you will learn all these things. Mathematics also. So when velocity will be c, his mass will be so high, close to infinity, and length will be so small, that is 0. That is possible? No, not possible. So never someone can move with velocity of light. Clear? Thank you everyone. We will meet with our video 2. There we will discuss reflection.